we've had a series of talks. We will again have a series of talks. But the difference is we've been in two separate rooms, and each room has been curious. I wonder what's going on in the other room. Is the discussion more interesting? And so we said, let's bring everyone into one room. Let's have at least a session where we're all in the same room. Someone asked me, how did you decide which 2-3 papers get to be in this session? And I'm going to say, look, LLM decisions come with no explanations. So get used to it. No explanations provided. So our first speaker is David Schweidel, and he's going to talk about generative AI applications in branding. So over to David. The way we're going to run this session, slightly differently than before, 3 speakers back to back, and then I'll invite them to come here and then some Q&A after that. Okay, David, thank you.
Thanks a lot, Kartik, and thank you. Before I jump into the work, this is joint work with my collaborators, Mark Heitman, Martin Riesenbichler, and Timon Jansen. And last year, Martin was out here talking about the potential for generative AI to be used for SEO and for paid search. And what we looked at in this paper was the possibility of, can we use generative AI for image-based advertising? You might think, well, we've got image generators, but the challenge with those image generators is that they're not designed to produce marketing content, right? I put in a prompt, it gives me a wonderful picture. I know some of you in the audience, I made myself a grumpy cat Iron Man that I have hanging on my wall in the office, and it's fantastic. But the purpose of putting in a prompt doesn't mean it's going to produce content that's going to drive the behavior that businesses want. So that's what we wanted to look at in this case. Being at Emory, I feel obligated to have a slide about Coca-Cola in here, but I wanted to share with you how are companies using generative AI. So this is what Coca-Cola did last holiday season. They took their digital assets and they opened it up to the community, saying you can come onto our website, you can create content using our digital assets that typically aren't available to the public, and you can create content that you can then share with others. And this drove a lot of traffic, a lot of engagement for the brand. So how can other brands take advantage of generative AI? Well, I'm going to show you 2 different ways that they can do this. One way that they're going to be able to leverage generative AI is to drive down cost. We've seen it in text-based generation. We see it again here. That you think about the cost of producing marketing content. Think about the process that you go through working with an ad agency, the brand manager working with that ad agency, preparing the brief, going back and forth, trying to be on the same page, and then the revisions that have to happen based on that creative. All of that time is going to create a cost. Can we cut down on the costs necessary to produce content that is going to elicit the reactions that we're looking for? So we're going to save money. The other way that we're able to see generative AI being used by marketers is that it's going to perform as well, if not better, than traditionally created content. Right? So we're going to look at the online advertising space. Just to give you some statistics, massive industry, key way of driving awareness. You know, I'm going to do a programmatic ad buy. I want to put this in front of as many eyeballs as I can. Right? Well, the approach that we're going to take is to use an open source image generator. So we're going to use Stable Diffusion, and we're going to train that model on 3 distinct concepts. The first concept is, if I'm going to use generative AI to create ads, I need it to accurately reproduce the product that I'm advertising. So we went out, scraped images of a particular model. In this case, it's the Polestar 3 vehicle, so that we could train Stable Diffusion to produce that vehicle. Second set that we're using for training is advertising. We need to have ad content from that particular category. So again, went out, scraped a lot of online car ads. But what we do in this case is we need to find out which car ads are actually good. Now, brands that are doing their own advertising, they're going to have this information. They'll have information like the click-through rates, like the conversion rates being driven by different ads. So they can use that. We didn't have that information. So what we did was to conduct some marketing research. We got an online panel, showed them 5 to 10 ads each, asked them to rate those different ads on the purchase funnel metrics. And then what we did was to say, let's take the top performing ads and train the generative AI on those top performing ads. So first step is learn the product. Second step is learn the category. Last step, we're going to borrow from some of the research that's appeared in marketing science and say, I want to teach an image generator to produce images that are consistent with particular brand personality dimensions. So in the case of an SUV, we said, let's train it to produce an image that is rugged, and let's train it to produce an image that is perceived as luxurious. So at the end of the day, these are the 3 data sources that we're using to fine-tune the image generator. All of these go into the model. The procedure that we use is from Google Research. It's the Dream Booth process for the fine-tuning. This is what the market research component looked like. Here's an ad evaluated on the following dimensions. So just to summarize the workflow that I'd laid out, data collection largely coming from Google. We scraped Flickr for images that are rugged and luxurious. Then we have our marketing research module. Again, this is something that brands wouldn't have to do if they already have this data. Fine-tune the model and use it to produce a series of ads. And the ads actually look pretty good. Right? You see on the left the ads from the competitors, in the middle ads from Polestar, and then on the right-hand side, AI-generated images. Right? So overall, do they look good? Yeah, it looks decent. It looks like a car ad. When we tested this using consumer perceptions, that I'll show you in a moment, from a perception standpoint, the AI-generated ads perform at least as well as the traditionally generated ads. But one of the fair comments that we got from reviewers was, well, this is nice, but it's just survey data. How do you know that this is actually going to work? So my co-authors took it upon themselves to say, you know what? Let's put this out into the field. Let's buy advertising, and let's see what the response rates look like. So we took these, actually I feel like I'm missing something. Well, we ended up taking a subset of these ads combined with an actual ad and put it online and said, let's see how the evaluation looked. Right? So here's the survey-based data that we have. The blue distribution showing us how did the AI-generated ads perform? The red bars, these are the actual Polestar ads. The gray distribution, the response that we got to the market competitors. And the piece that I draw your attention to is that the distribution trained on high-performing ads to begin with is shifted entirely to the right compared to actual ads. We actually see the best of the AI-generated ads, better than all of the Polestar ads, better than a good chunk of the competitor ads. So surveys tell us this is working. Skip through the eye chart since we're limited on time. So here are the ads these are what we put online. So 10 ads look reasonably similar in many respects. And we said, let's look at click-through rate. It'd be ideal to have conversion, and if there are any industry partners in the room that want to go out and test it, by all means, we're happy to have those discussions. The bottom right is the actual car ad from Polestar. So all of these ads had the same text. We kept that text constant. We put this on an ad network. And here are the click-through rates that we got associated with it. So the actual ad click-through rate of about 1.2%. You see the AI-generated ads the average is nearly identical. They're distributed around that 1.2%. Some are better, some are worse. Right? So at a minimum, we say AI-generated ads performing in terms of click-through rate on par with actual ads. What we're looking at doing next is saying, hey, we've got 4 out of the 9 AI-generated ads that are outperforming that actual ad. What if we were to fine-tune one more time the image generator and say, let's iteratively fine-tune this image generator based on what is working well. So that would give us an opportunity to explore that generative space and identify those ads that are performing well, put more weight behind those ads, less weight behind the ads that are underperforming. One of the things we're seeing as a possibility with generative AI is the potential to change the way that we think about experimentation. If we think about experimentation starting with A/B testing, going to multi-arm bandit. Keep in mind with the multi-arm bandit, it's a fixed set of options and you're reweighing those options. With generative AI, there isn't a fixed set of options anymore. We can generate virtually an unlimited number of options. The challenge becomes how do we efficiently navigate that particular space? So we have evidence that shows us, yes, it's possible to use generative AI to create visuals, but can we do more with this? And so one of the other experiments that we ran was looking at the potential of incorporating generative AI into personalization. So we conducted an experiment where we asked people how important the rugged dimension was to them. And for some individuals, we showed them an image that was created saying, I want a high-performing Polestar ad that is rugged. Others, we created images that were just a high-rated Polestar ad. So we manipulate in the image generation, was it designed to be rugged, yes or no? We have people that tell us, yes, I'm interested in ruggedness, or no, I'm not interested in ruggedness. And we get the crossover pattern that we're looking for with the interaction. And so if we look at the people who are shown the images that are not based on ruggedness, roughly the same performance, whether you care about ruggedness or not. But for the people who tell us, yes, I'm interested in ruggedness, this is something that matters to me, we get better performance in using the generative AI to create an ad that was trained to be rugged, rather than showing the rugged ad to people who are not interested in that. And so this is done using, again, survey data to create this median split segmentation. But imagine working with a third-party data provider that has profile information. I now have the ability to say, let's build these different profiles. Let's generate ads that are designed with these particular profiles in mind, and let's incorporate that into an active learning framework where we're not just showing the same set of ads going forward anymore, but we're updating over time based on what we learn in order to make those ads more effective. So as far as what does this mean for marketers? Yes, generative AI is something that we can use, but we have to give some thought to how we go about doing it. Off-the-shelf generative AI tools that are out there, the Midjourneys, the ChatGPTs, they're not trained with business in mind. The business objective is not what they're built for. They're predictive models. If we combine the digital assets that companies have along with these pre-trained models and bringing in consumer input to tell us this is what works well, this is what doesn't work well, that's the combination that's going to be necessary to kind of unlock the full value of generative AI. And as I mentioned at the outset, we're not just looking at cutting down on the costs of content creation. We're also looking at the potential to create content that performs better than content created through traditional means. All right, thanks a lot.
Thank you, David. Our next speaker is DK Lee. Going to talk about using LLMs as human surrogates.
All right, thank you for having me. It's a great pleasure to speak about this new paper with my first year student, Yuan Gao, Boston University. He literally started like 3 days ago. Quality of PhD students is getting out of hand. So this is titled Take Caution in Using LLMs as Human Surrogates, Scylla ex Machina. That means Scylla from the machine. And also joint work with Wharton Birch at Boston University and Scylla at Northeastern. So let me just start with a description of Scylla, because I'm making this She has 12 misshapen feet and 6 necks of the most prodigious length. And at the end of each neck, she has a frightful head with 3 rows of teeth in each. So this is Homer's Odyssey describing Scylla. Okay? So there has been a lot of papers, some probably some of the authors in the audience, suggesting LLMs can be used to study human behaviors or as a human surrogates in political survey, economic experiments, psychological experiments, as well as market research. Right? So related to this, there has been ongoing discussion in language models called stochastic parrots, which says, it talks about the idea that language models generate plausible text without genuine comprehension. And this has been active area of research. But this goes back originally to a Chinese room argument from 1980s. John Searle has been talking about that. And even before 1956 Dartmouth conference and then imitation game, right? So this has been an ongoing argument. So this argument applies to all modern language models using autoregressive model. Right? And big researchers like Yang LeCun, Noam Chomsky, and many others for many years now have been saying things like autoregressive LLMs are doomed. And they are proposing we need a new architecture, right? Everybody here knows about hallucination. There's a recent paper showing that the theory paper showing that autoregressive language model hallucination is inevitable. Okay? This has actually made a viral, it became viral in CS World last year, I think, where LLMs trained on statements like A is B fails to comprehend B is A. And this is due to the power law of of LLMs seeing different examples, and it'll fail in all cases. Also, shuffling labels in fuchsia in-context learning still work. So, remember, in-context learning just means it's just inference. There's no updating of weights. But if you just give it a few examples and then answers, the idea is that it's going to learn from these examples and make an inference. Now, there's a paper, this was actually 2022. They shuffled the labels and it still worked. Okay? Here's another paper, came out a few months ago, chain of thought reasoning. Chain of thought, you guys probably heard this repeatedly mentioned today, right? Prompting improves LLM's performance by deconstructing the reasoning process into intermediate steps, and it works well. But there's also peculiarities. In some cases, substituting these reason steps with meaningless tokens like dots still work because it increases the inference computational length. I mean, it doesn't work for all times, but again, peculiarities, right? And memorization data leakage is a huge issue right now. For example, rephrasing well-known LLM benchmark testing resulted in dramatic decrease in performance because that was memorized, right? It's still a nascent and very active area of research. This is a figure I took from a paper. They look into impact of contamination detection and mitigation, okay? And also there's a paper showing that what's hard for humans, might be easy, might be, what is easy for us might be very hard. Right, so that's not a surprise. And I can go on, but there are more limitations and peculiarities that's coming out every single day, literally every single day on arXiv. So, and emergent ability depends highly on pre-training data, instruction tuning, and data augmentation. And this is very fragile and stochastic. And if you want really good set of papers, I highly recommend this physics of language model. Okay, he has done a series of work showing these peculiarities. For example, even the latest model, like GPT-4, in grade school math problem, if a step required to solve it goes over like 11, it fails, okay? So current LLMs are a completely different form of intelligence, and we need to stop anthropomorphizing this LLMs, right? A lot of papers showing temporal reasoning is lacking, probabilistic reasoning is lacking, counterfactual, spatial, ethical, common sense, they're all lacking, right? But this is expected because why? Well, because objective functions are completely different. We have evolved over millennia as a physical beings on Earth trying to survive, right? Our objective functions are built in DNA and millennia of evolution. LLMs did not. So we cannot expect them to have the same function or objective to behave in a similar way, right? LLMs are also not embodied. They don't have a body. I mean, some do, but the ones that we use are not embodied, meaning they don't have sensory motors to interact with the real world, to learn from the physical reality that is law. It learned from textual data, right? All these arguments and theories go back decade, actually. Let's also talk about the engineering side, the data. Well, 1 to 15 trillion tokens online is not nearly enough data. It loses all the non-digitized contextual information. This is why the running theme of incorporating human and AI is the best way, as a lot of presentations today have shown. The data is also selected. Polanyi's paradox, what we know that we cannot verbalize, obviously cannot be digitized. So that will not be, trained, right? Also, even if you have, really, truthful data, there's also what's called aleatoric uncertainty. The model level is statistical, so there will always be an uncertainty, right? Given this, we cannot expect LLMs to behave fundamentally like humans. It's a totally different form of intelligence, right? And you can read this philosophy of artificial intelligence, which goes a lot into this. And one of the best book I think I really like to get an insight into AI, what is AI, is this Mind's Eye by Douglas Hofstadter and Daniel Dennett. Of course, you should have already read Kartik's Humans Guide to Machine Intelligence and Decision-Driven Analytics by Stefano, right? So I did not present it here. But this will give you a very good insight into what an AI can do, okay? So now we go into our experiment, 1120 money request game. This is a very simple game, peer of mind related game. So you and another player are playing in a game which each player requests an amount of money. The amount must be an integer between 11 to 20, and each player will receive the amount he requests or she requests. A player will receive an additional 20 shekels if he or she asks for exactly 1 shekel less than the other, right? So this is a game theory, right? Beauty contest kind of game, right? This is level K thinking problem. I know that you know, and that will determine my best action. I know that you know I know, and then so on and so forth. It goes into K level. Best response is very straightforward, selecting 19 in response to 20, 18 in response to 19, and so on and so forth until 11, right? We run this game 1,000 times in separate sessions in a popular LLMs. We chose this because of simplicity, solid foundation, close relation for comparison like beauty contest game, but it's less prone to memorization. It's less well known than beauty contest game. None of the model we test can correctly replicate the instruction of the game. We also try a bunch of different memorization technique. There's no silver bullet, so we try a bunch of them, and most of them, like all of them said, these models do not really know this game. All right, so here's the first result. LLMs consistently show lower levels of reasoning than humans in our game. So this is a graph. On the y-axis, you have a bunch of different models. This is a human distribution. So this is, again, x-axis is response, right? 11 to 20. And this is a distribution. And you have a Nash equilibrium, GPT-4, GPT 3.5, and everything else kind of fails. The closest one is GPT 3.5, right? Unlike LLM's performance on other related experiments, there's actually a paper that tried this in a beauty contest game. And in there, they show that LLMs actually do perform like humans or even higher level thinking. Okay? LLMs generally fail to generate human-like distribution, as you can see here, right? Third, some LLMs responses align more with Nash equilibrium prediction. Human responses frequently diverge from Nash equilibrium, you can see here. Lastly, behavioral patterns across LLMs vary significantly, and we found out that larger models not necessarily better, right? For example, like 3.5 was better in most cases, right? We also tried zero-shot prompting, chain of thought, doesn't improve it too much. We also tried a bunch of different things like emotion-based prompting, like telling this is very important to me, and then this is shown to work well. Opera-based prompting, optimization through language prompting. That's the Google DeepMind. You may have heard of that prompting technique, take a deep breath, and it improves. We tried that. Didn't really, it changes a bit, but it doesn't really, you can see the similarity to the humans is still kind of low, right? We also tried few-shot chain of thought, and giving different examples actually changed the LLM's behavior. So here on this side, we have given 3 examples ranging from 18, 19, 20, and the rationale for that. And here we gave an example giving 11, 12, 13 as a response, and then you can see the distributional difference. It's very much shifted towards that example, right? And we also did fine-tuning and RAG. So you can see now, once you do fine-tuning and RAG, it's behaving more like humans. So it has learned, right? Summary, in all out of distribution settings, zero shot, in context, chain of thought, emotional, all-pro, LLM failed to exhibit human behavior. Only when it was not out of distribution, few shot COT, fine-tuned RAG, it began to mimic human behavior. This was just one very simple game, and you see these peculiarities. Catch-22 here is that it may not generalize to out-of-sample distribution. It may only mimic things explicitly taught or shown. Highly stochastic based on what was shown. In this case, it's a behavior or data we already have, transformed in a way that we don't really understand, right? LLMs are very capable and can accelerate or is amenable to p-hacking, begging the question type of fallacy or garden of forking path, right? LLM is a perfect tool for that. So mathematical models work because it's grounded in physical truth. Mathematics, right? LLMs stand on 15 trillion tokens at best. Now multimodal, but it's not the truth, right? So using current LLMs, I don't know when this will change, nobody knows, right? Current LLMs to study human behavior is like interviewing a parrot to diagnose mental health issues of the parrot's owner. Trying to diagnose skin condition through reflection on water, okay? Whisper to the model long enough and it will shape its echoes to match your desires, right? You don't want to get stuck in an LLM echo chamber. We have no way there's no function to predict how LLMs will behave. You don't have an epistemic correctness function which measures when an LLM output coincides with reality. It does not exist. If we did have that, we could really use that function to improve the quality of LLM in a snap, right? We don't. Humans are bad at predicting what LLMs can do. It's quite obvious. I mean, how could we, right? It's billions of parameters. And there are lots of challenges in quantifying LLM uncertainty, okay? And current use cases, the entire this conference is about it. I've seen awesome use cases, so that's all great. I am a big fan of LLM as a tool, drafting, honing, starting points, iterating, etc. Automated hypothesis is an awesome use case for humans to filter through, right? LLMs excel in combinational creativity and novelty. It's very easy for novelty. Now the value is hard. I think that's where human and AI could come in. And we've seen a lot of cases here today where LLMs are being used to help humans filter through things. Value assessing and filtering, best left to humans or humans plus LLMs, as we have seen. And we have this, speaking of great students, we have this paper, How Gen AI Impacts Human Creativity. That's a paper, you can check it out. This is with Eric Zoe here. And lastly, I leave you with this epic poem style warning, okay? Scylla ex Machina, born of the Transformers' might, beware its mimicry of human, for its many attention heads, chaos lies concealed. Trust not the stochastic surrogate, lest you fall to Babel's curse, the price of misuse. Thank you.
What I thought was interesting was here you have 2 papers, one talking about how AI is effective in advertising, AI is effective in customer service, chatbots, and then you have a warning, AI, don't expect it to replicate human behavior in many settings. This is not evolved like humans, all these differences, watch out, a lot of warnings, which I think mirrors what we're seeing, lots of companies trying to do things with AI, lots of case studies that seem to work. but then lots of, when it comes to deploying at scale, we start to see problems as well. I think it's a really nice setup for this conversation. I'm not going to ask much. I'm just going to open it up and mostly do pointing of my fingers. But I'd love for you folks to jump in. I think the comments or questions could certainly be about the paper, but they don't have to be. It could just be about the broad theme of this workshop. And we've got 3 highly capable people who can comment on things beyond their papers as well. So with that, any questions, please raise your hand. Please use the mic. Each of you has a mic, and this session is being recorded, so it's important you use your mic. You have to keep holding that button and make sure the light is green as you're speaking. Hemant.
Go. So this is the hard one. Hold the button. All right. So I think all 3 talks were really interesting, but I'll start with you, David. I think this idea of having the AI produce marketing content, right, and that you mentioned cost and time savings. So it made me think, how were the humans doing it before the AI, right? And you could think of all the way going from a drawing board and developing sketches and so on. Or you could think of a human producing those images by saying, oh, I'm going to pick this. I have this library of vehicle images. I have a library of backgrounds. I have some effects. I put it together, and maybe that would take a good human 5 minutes or 10 minutes. Right? I have no idea. I'm just curious how that affects this cost time performance, because if it's one way or another, because when we say AI, like at what point was it AI? Like what about all the other tools you have access to before the AI? So how do you even approach this question of the AI versus human?
I think it's a great question. I think one of the challenges that we're going to see, especially within marketing, is we're going to have to fundamentally rethink the client-agency relationship, because there's going to be this question of what are you paying for? One of the favorite examples I use in class is there was a woman who, world-renowned designer. She had designed the Citibank logo after the merger with Travelers Insurance. It's the city with the umbrella. And she drew that image on a cocktail napkin. And the CEO for Citi said, I'm paying, I forget what the number is, say I'm paying $5 million for something you drew on a cocktail napkin in 5 minutes. And the response was, no, you're paying $5 million for 20 years worth of knowledge that allowed me to draw it on a cocktail napkin in 5 minutes. And so I think, to your point, somebody who's highly skilled, it's not going to take them that long to do something, but you're going to pay for the fact that they are highly skilled. And what we're seeing generative AI can do is really take that skill set to scale.
Thank you.
Yeah, a question there, Amit.
So I have an observation that has repeated itself in many papers through the day. In Eric's talk in the morning, he was talking about the call center example where also the performance of the low performers actually improved, whereas the high performers did not improve. And in Lauren's talk, same kind of a thing, in fact, even worse. The high performers actually, their performance declined. So I'm thinking
they did speed up.
So what I was thinking was, why can't high performers learn from each other? Because I may be a high performer in one dimension, somebody else may be a high performer on another dimension. And if somebody is a high performer, perhaps because they have got like a lot of motivation to learn. So why can't they actually learn from each other? What is holding this back?
I don't think I have an answer to the question, but I do think that all of these initial findings of the effect of deploying Gen AI in various business functions does give us a caution that organizations need to think about their human employee training, think about how they could change the incentive structure, how they schedule the task, design the jobs to incorporate AI. So a lot of things are going to change.
If I may jump in and just add to that, sorry, I don't have a paper in this session, but Mary was kind enough to give me a chair, so I'll also jump in. So I have a paper tomorrow where I'm going to elaborate more on this theme. But the theme is, I actually think the way you deploy AI for high-skilled workers versus low-skilled workers needs to be different. So we have a study where we look at AI for creative writing. And even in that setting, we see that the lower-skilled writers, their performance goes up a lot. And high-skilled writers, in certain designs, their performance drops. But there are certain ways in which actually, they do benefit, and it comes down to how you actually deploy AI. What's the mode of collaboration of human and AI? And there's many ways in which you can design human-AI collaboration, and I think that's probably, at least from my perspective, the one big theme in terms of how you make sure AI actually benefits, workers of different types.
If I could add a bit to that, so it's funny if you talk to everyday people, they say now we're going to rise to become like the mastermind, right? When you talk to people like Dean of Juilliard or like Jeff Goodby, that creative advertising mastermind, they're going to go even further up because they have the skills and So we have like the paper that I wrote with Eric, we have this actually an evidence where it's all about the complementarity, right? So we saw, for example, in art, people who are visually good, creating visual stuff did not excel because they, what counted was ideation ability, right? So it's all about, I think, low-skilled workers benefiting, high-skilled workers not benefiting or benefiting less than, lower skilled worker is, I think, nuanced. It requires more nuanced perspective. It's all about complementarity. We had that paper, right, from the different session. Yeah.
Great, we'll take a question here.
Yeah, I want to connect this question to the job market situation. In the IT industry, the workers most intensively use the generative AI technologies. In these days, early stage of the programmers, the job market is shrink. So the low-skill workers get a lot of help from the generative AI, but in the job market, why the doors for the early stage IT developers getting smaller and smaller? How can we connect these two?
We all have speculations, but I'm going to invite, we have a bunch of industry participants here. If someone has an opinion, I'd love to hear that. The question was that we're hearing about all this research that shows that AI improves productivity of low-skilled workers and could be a great boon for low-skilled workers. But we're also seeing in practice that hiring at lower levels, junior levels, is going down, especially if you look at software engineering and so on. As AI increases productivity of a lot of people, a lot of companies are slowing down. Of course, there's a lot of things confounding this whole observation, from what's going on with the economy to what's going on with AI use, all of those factors. But curious if anyone has an opinion. If not, we're happy to jump in. Yeah, Anand.
Yeah, Kartik, I think I wanted to say what you were saying, the macro trends of where the economy is with the hiring. I think at least in the software engineer perspective, I would hypothesize that hiring in the middle is where it's going to go down, because on both ends, you're seeing value with AI. If you look at AI for code gen, there's a lot of interesting studies that are coming out that are showing that low-skilled workers can actually deliver a lot more with those tools. And even for high-skilled workers, the time to task completion also significantly gets reduced. So if anything, I would hypothesize in the middle is where we see the problem, not at the early in-career hires.
Right. I think one other effect is also just that we have seen a significant boost in productivity of engineers all over in the last 12 to 16 months, which also means that hiring slows down because you can get a lot more done with who you have. And when hiring slows down, we certainly see that we see it at all levels. Even very senior people, are affected by it. But certainly, we see it a lot at the junior levels because of the numbers. Yes, sure.
I think the way I worked with the fintech company in the past, so fintech industry. So what I find that's interesting is the exact opposite of this statement. They find that the middle level of the employees really benefit from AI, but the rookies with the lower skill employees they're overwhelmed by AI suggestions. They don't like that. They do not learn that much because there's AI can generate so many good advice, but you are just do not understand, overwhelmed, too much good information. The top workers, they have a psychological aversion. They don't like AI boss them around. So they have a quite aversive, even the good advice, the top workers are thinking, no, I've been in the industry for so many years, so I know what I'm doing. So they going to kick back the AI advice. So it's only the sweet spot is the middle level of the workers. They have some experience of the company. They see the AI suggestion works, right? So it's making it useful, they learn faster, and that's why they benefit the most. So I was like a question to Lauren's work mostly, and also Eric's in the morning work. It depends how you split your data, the lower skill and the higher skill. If you have kind of quintile or decile, probably you see some kind of pattern, nonlinear relationship over there.
In fact, I skipped the slide. We did slice it up by quintiles, and actually it's fairly monotonic. It's the top quintile agents that experienced decline in service quality.
Yeah, so probably that's a different industry nuances. So one of my prior work, which you cited over there, was university in the middle tier worker that benefit the most from AI. So it could be different.
In this setting, the capability of the AI agent, AI assistant is very limited. It's that 3 lines of text, that's all.
Okay, we'll keep this moving. We have 5 minutes left, maybe a couple other questions here, Raghu.
Very interesting. So 2 questions for Lauren. One, it's your data are hinted at it. There was concurrency or the number of sessions that was the reward for the agent.
The concurrency is basically multiple chats that
That's
they
right.
handle
Yeah.
at the same time.
So was the reward or the incentive the number of
so
chats?
these agents are paid on a piece rate and also with some performance bonus.
Okay, so not specifically the outcome would have been the CSAT or the rating of the customer from that particular interaction.
Not per call, but aggregated at the monthly
Okay.
level. You're given a sort of a performance index, and then your bonus is
Got it.
dependent on that
Yeah.
performance.
One way so I work for Google, and one way that we're doing this agent split between high performers and low performers, we're reskilling the high performers, meaning that they will then become the supervisors for the model. So they basically then value add, right? Like you're building their skills in terms of enhancing the quality of the models. So that's one way. I'm not saying that it's being done.
I think many organizations will have to start to do that because otherwise your LLM is going to plateau.
Yeah, correct.
You need
Yeah.
human intelligence to constantly refresh your LLM to push the envelope.
Yeah. My second question, thank you, to David. Did you consider placement of the ad? Because that's a big factor, like association with being high tech or with even like the background or imagery that might be correlated with where you actually place the ad.
Yeah, we did not vary placement, so we used Tabula's network for running for running the field experiment. But certainly the content that it's placed with, the size of the ads, there are a lot of factors that could have an impact on overall performance.
Okay, thank you.
Okay, if you have a good high-level question, I want to close with something. Now everyone has their hand down. All right, good.
I'll try.
No pressure.
So this is for DK. Thank you. This is for DK. So the notion of, you kind of came harsh on this notion of synthetic respondents, right? You have an opinion, a strong opinion. But synthetic respondents is like simulating data. That we have a very strong tradition of that in scientific discovery. So I wanted to ask you, one of the findings you had was in order to try to mimic people, RAG works, in-context learning works, fine-tuning works. But you, at least my impression, you kind of tried to downplay that a little bit. And so I just wanted to hear your sort of reason for why you want to discount that finding versus sort of the main claim that you wanted to make that?
Yeah, I mean, so I'm not that discounting that. So I think you could make it, the main point there was that you could, LLMs are highly capable, so you could really make it mimic. But what I was against, opinion is, like, the keyword is current LLM to study the human behavior, right? Or humans. I think you could, this is not to say, let's make a synthetic, consumers and then see what they say, and then after, managers can look through and filter through what might come out. That's an absolutely great use case. But to study, what I'm against is using current LLMs to study something about humans that we think we can, because of all these peculiarities, like failures that we really don't understand.
I love what you said about the Wharton paper and then sort of hypothesis generation stuff, right? That's super clever, and then it's a good use of LLMs for creating hypotheses and then perhaps testing them with humans. So there's a clear sort of value add for synthetic data for scientific discovery, right?
So Chen Ao Tan had a paper before that. There's a CS person, and I think many people had. Let's try to use LLMs to give us novelty, and will be the value filter. But I think to use automated LLMs to automate filtering, I think without any human, we don't know how it's going to work out, because all of the behavior is, for example, error correcting ability of LLMs cannot be fine-tuned in, according to at least one study from the physics of the language model. It has to be pre-training data. So then that's just one ability, right? So how do you expect, these to find, certain things that may be true of humans from LLMs? So what I'm saying is, like, let's have human in the filtering process and valuation. And if you just rely on LLMs to do valuation without human intervention, we have no way how this is going to work out due to bias and all these things. It's just too complex. And it may spew out things that are just BS, and we know it's very good at doing that, right? So I think at the end, human has to be part of that filter.
Yeah, but I absolutely agree with that. And I'm presenting a paper tomorrow that sort of makes exactly the case, what you just said. And we do make a case for simulated data, and so slightly sensitive about this.
No, we will still show up for that talk tomorrow. All right, I think, you want to jump in?
If I just say, I think one of the concerns is, or one of the challenges we have is, how do we choose to use the LLMs? So, for example, there's one marketing research company that was started by the founder of YouGov, Brox AI. And their approach to using LLMs was to say, I'm going to get a panel, I think they have about 40,000 individuals, and I'm going to train an LLM on a particular individual. That's different from saying, let me use an existing LLM to try to simulate a panel. So I think that's still one of the pieces that's unknown, is how far can we push the use of an LLM to kind of simulate a distribution of behavior rather than using it down to the individual.
Great. I think there's a lot to flesh out here. The discussion does not need to end right now. It can continue in the hallways. So that's exactly what we'll do. We'll take a quick 25-minute break. At 5:30, we'll reconvene in this room for a very nice fireside chat with our dean and thought leaders from Accenture. So more on that shortly. So 20-minute break, 5:30, we reconvene. Thank you all. Thank you.